plan for today is we're going to finish up talking about the material that we talked about last class before the test, and then we'll do the new stuff for lesson 28. So when we left off last time, we talked about multiplying fractions and dividing fractions, and I'll remind you how to do those two things after we finish this kind of problem here. I asked you to skip this. You did some of the activity, I think, starting on the next page here. So let's just talk about this stuff that I asked you to skip. What I want us to do is plug in x equals 5 right there. Yeah, just send that around. Thank you. So if we plug in x equals 5 for all of the x's that we see, we get 5 plus 4 over 5 minus 5. Everybody see what we did? 231. 231. So upstairs we get 9. What do we get downstairs? 0. That's interesting. What is 9 divided by 0? 0 is a very common wrong answer to that question. 9 divided by 0. 9 divided by 0. Not 9, not 1. It is. It is exactly like undefined. Right? It's undefined. We cannot divide by 0. Undefined. All right, we've been taught from a young age you cannot divide by 0. If you don't believe me, surely you believe the calculator. 9 divided by 0. Oh. Error. You cannot divide by 0. Okay, so that means that we can have a problem like this thing. Let's take a look at part A. And we can ask the question, for what values of the variable is the fraction undefined? So the word undefined is exactly the one that we just saw. You cannot divide by 0. So if you see undefined, you say, oh, that means the denominator cannot equal 0. So I'm going to write something right here. You guys can write this too. It's about the denominator. And I want this denominator to not equal 0. All right, I'm going to write something, and then I'm going to, yeah, so I'm going to write this, and then I'm going to erase it. So don't write this for just a second. What I really want is to make sure the denominator is not 0. Yes? Okay, but we have like no experience solving not equations. We have plenty of experience solving equations. So we're going to solve for the thing that's bad, and then we're just going to acknowledge, hey, these are the values of x that are bad, right? So what I really want to do is avoid 0, but I'm going out of my way to make 0, and then I'll say at the end of the process, just don't let x equal these numbers we're about to find. Okay, solving a quadratic equation equal to 0. Could use the quadratic formula. This one does factor, so I'm just going to write the answer. That's good, thank you. So that's maybe a 2-minute process for some of us between those two lines. It's a 2x2 box. You can take your time with it. We're not going to spend our time right now doing that. And then we get to split into two simpler equations, right? Either one of these two things in the parentheses has to equal 0. So on the one hand, x equals 1, and on the other hand, x equals 10, right? And then we just point out that the fraction we just built does not like those numbers. The fraction is undefined at x equals 1 and x equals 10. That's a quick check just to really make sure we're clear on what we have found here. If we plug x equals 1 into this thing, I'm just going to pick one of them. Upstairs, 3 times 1 plus 1. Downstairs, 1 squared minus 11 times 1 plus 10. What do we get upstairs? That's 4 divided by downstairs, 1 minus 11 plus 10. It is 0. That's the point. That's what we built. We built a0 down there. So is it okay to plug x equals 1 into that fraction? No, it's not okay. We found the values of x that make the fraction not okay. Any questions on that? Also notice this fraction has a numerator and a denominator. Which part did we completely ignore for this problem? The numerator. It made absolutely no difference. It might feel to some of you like we're showing favoritism and it's not okay to just ignore the numerator. I'm telling you, it's okay. To make a fraction undefined, all we care about is the bottom. The top could be anything. It made no difference to me that it was a 4. Right? It's really having a 0 in the bottom that's the key. So you see a question about making a fraction undefined, you immediately translate that to denominator equals 0. That's it. Any questions on this one? Okay. On the next page, all right, so we did some of these in the activity. I'm going to jump here, and I think we'll find a problem that nobody got to. 233. 233, we're going to do part B. I don't think I gave folks enough time to get here during the activity 2 classes ago, so let's try this guy. All right, first observation, this is 2 fractions. What symbol is between them? Division, so this is a division symbol. And every time I have to divide 2 fractions, my process is exactly the same, no matter how intimidating all of those pieces of the fractions are. Does that first fraction get copied or changed? First fraction is copied, just as it is. And we change that division symbol to something that we can work with more easily. What do we change it to? Multiplication. Every division problem turns into a corresponding multiplication problem. But you have to pay for that change. What do you do with the second fraction to pay for the change? Flip it over. So I say again, every division of 2 fractions starts this way. Even if you can't do anything further on a problem like this on the final exam, you'll get some points for doing the first step. Okay, you will lose lots of points for canceling a squareds because we cannot. Remember we saw last time that you can only cancel when it's multiplication, and each of those a squareds has a plus next to it. Neither one of them is cancelable. You can't cancel 15 and 10, even though they're both divisible by 5. You can't cancel the 9s, can't cancel anything. So the next step was to turn all of that addition and subtraction into multiplication by factoring. Everything gets factored. Equals. Let's go ahead and get some shells in these fractions. I'm going to jump to the bottom right one first, hoping we recognize this pattern. It's a difference of 2 squares. So what is it? A plus 3, a minus 3. It's okay if you change the order there, but the a minus 3 first is fine. The other 3 sets of parentheses are all more work than the one we just did. They're all 2 by 2 boxes. Again, we're just going to write the answers. It's okay if you take your time doing this. A plus 5, a minus 3 on that first one. Plus 5a minus 2 is good there. And I think it's a minus 7, a minus 2 on the last one. So how do we get those factors as quick as I do? What can I say? I'm a 2 by 2 box genius. That's what I was born to do, I guess. All right, honestly, there are faster ways to do certain of these problems without the box, and I am applying techniques that I have not shown you, but maybe you saw in some previous algebra class. But the techniques that I'm applying here that allow me to do these problems really quickly go completely out the window if there's any number in front of that a squared other than 1. And I used to teach the specialized techniques that get you the fast answers, But then I had to do the 2 by 2 box anyway for the ones with a 3 in the front, and I just decided at some point I'm going all in on the box. No need to fill your brains with like specialized case after case after case. The box handles them all. I don't mind that it takes a little bit of time. What's that? You can learn it next class. You can learn it today if you ask me. It's not a secret. Okay, now it's all multiplication. And now we are ready to just cancel any things that are exactly the same. Any numerator with any denominator that's a copy. What do we see? A plus 5, A plus 5. Cross them off. What else do we see? A minus 3, A minus 3. Wait, can I cancel? Oh, that's in one fraction and that's in the other. It's multiplication, right? There's no two fractions here. When you multiply fractions, you go straight across as one fraction. Don't put any restrictions on here. Any numerator with any denominator. So yes, absolutely. Cancel those. Anything else? A minus 2, A minus 2. And then we copy what's left. What's left on top? A minus 7 or A plus 3. And then finally, cancel the A's. Get negative 7 over 3. Oh, you guys caught me quicker this time than last time. That's no good, right? I mentioned this before. Oftentimes people will have the right answer. They'll have the right answer for me on a test or the final, and then they'll go too far, and they'll get the wrong answer. So we cannot do what I just did. All right, I think we're good there. That's as far as we go. Right? It's tempting to cancel the A's. Did I convince you? Did you? Yeah. See, you trust me too much. Okay, so that is how we tackle division, turn it into multiplication, factor, cancel. Okay, so that's all I'm going to say about the old stuff. Now we're going to jump right into the new stuff. So let us turn a few pages. We're looking for this one right here. 238, actually. 238. All right. Actually, let's go back one to 237. We'll do one quick example, one easy one, and then one hard one. So we're going to take a look at number 2 here. Again, I see two fractions. What symbol, what operation is between them? Subtraction. Subtracting fractions is entirely different from multiplying them, and it's entirely different from dividing them. Surprisingly, it's harder. Like you'd think multiplication and division would be harder than adding and subtracting, but it's the reverse for fractions. But in this case, it's not so bad. What makes subtracting these two fractions nice? They have the same denominator, right? That's the key. You know that to add or subtract fractions, you need to have the same denominator. Hey, this one already does. So we just subtract. Okay, I'm going to put the wrong answer first, and then hope that you catch the error here. If I subtract 9x squared minus 3x squared, what do we get? 6x squared. If I do this minus x minus 9 more x, minus 10x, divided by, what do you do with the two denominators? Combine them, like 6x plus 8? Leave it the same, right? Doesn't change at all. Like if you imagine a pizza and you have like 5 slices out of 8, and then somebody takes away 2 out of those 8, you have 3 still out of 8, right? The size doesn't change. The size of a slice doesn't change. Okay, that is the wrong answer. It's a really common wrong answer. Anybody see what we did wrong? Ruth, what sign? Yeah, Ruth is exactly on it here. We are subtracting. We are taking 9x squared minus x and subtracting the entire bag of stuff in this numerator, subtracting all of it. We didn't subtract all of it. We did subtract the 3x squared. That part was okay. But that negative 9x was supposed to be subtracted. And Ruth says minus and minus makes a plus, and that's right. We didn't subtract 9x, we actually added negative 9x. We should have subtracted negative 9x. So here is the way you are going to avoid that pitfall. You're going to write big fraction line. You're going to copy your denominator. You know that doesn't change. You're going to bring those two bags of stuff over here. But what are you going to put around them? Parentheses. That's going to be your way of making sure you recognize that these are entire bags that are getting added or subtracted. Okay, we're going to do 2 steps in 1. Feel free to write this out further if you'd like. 9x squared minus 3x squared is still 6x squared. We had that part right. This is now negative x minus 9x. That's really a plus 9x. So what do we get? Plus 8x. That's good. Yep. It's really easy to make that mistake. I encourage students to write that one extra step that we put in the middle, where you just make one big fraction. It might feel like you're wasting time doing all this copying, but you might be saving yourself a couple of points. Okay, this answer is most of the credit. It's correct, but it isn't simplified. This answer would be equivalent to me, like you giving me something like, I don't know, 5/20ths and saying that's my final answer to some problem. What would I rather you write? I'd rather you write a quarter, right? So you're obligated to simplify, reduce any final answer, right? And with fractions, there's ways to reduce them sometimes. Well, we saw last class, or I guess 2 classes ago, how to reduce fractions like this. Can I cancel, like x and x? I cannot. So what we need to do is make that addition multiplication by factoring. So let us factor. The bottom, is there a greatest common factor we can pull out? No. Difference of 2 squares? No. 2 by 2 box? And it's not an x squared. So there's nothing to do downstairs. But we play the same game upstairs. Can you factor out a GCF, greatest common factor? It is. We can take out 2x. And something kind of nifty is going to happen when we do that. What's left from that 6x squared? 3x. 2x coming out of the other guy? Plus 4. Hey, look at that. Can I cancel? Yes, I can. That 3x plus 4 and that 3x plus 4. Our final answer is 2x on top of what? 1. It doesn't matter in this case, so I'd rather you not put the 1, but I just want to show you. You got to bring in the placeholder temporarily at least. Right? So if you forget to do that, you'll lose a point or 2. Most of the credit is the previous answer, but it is one other thing you need to check for. Any fraction answer, you got to make sure that you do your best to see if it's reduced. Okay, so this is how we subtract 2 fractions. Adding is exactly the same. Again, what made this one easy-ish? Same denominator. So guess what we're about to do? Ones with different denominators. Next page. We're jumping right down here. Okay, this one is about as hard as they get in terms of adding and subtracting. In fact, it's got both addition and subtraction. I'm just going to highlight the 3 fractions so we can see very clearly what we are playing with here. We've got 2 fractions added and then subtract a 3rd fraction, okay? So here is the first step. We're going to rewrite all of this. It's done for us, whoops, it's done for us actually. But we're going to add some space to those fraction lines. So it's already written out here, but we're giving ourselves some space. You'll see why we wanted that space in just a moment. There's my 2nd fraction. What change did I make on this 3rd fraction? What did I do with that denominator? I factored it. Now, I didn't show the details, but this is another 2 by 2 box problem. You take that denominator and you factor it. If we could have factored any other denominator, we should have. So the first step with these is to factor all of those denominators. Students, again, feel like they're shortchanging the numerator. and they want to go factor the numerator. It turns out factoring the numerator is not only a waste of time, but it's actually counterproductive. So again, this is just about the denominators at this stage. Okay, so here's the technique. Adding and subtracting these fractions is hard because those denominators are what? They're different. So we have to do a lot of work to make them the same. That's the key. Once they're the same, it becomes like the problem we just did on the other page. So let's look at just the first two denominators, y minus 4 and 3y plus 4. They are different. I'm going to make them the same as each other. Here's how we're going to make them the same. I'm going to say this first fraction does not have a 3y minus 4, so I am going to give it a 3y, or I should have said 3y plus 4. So go ahead in that blank space down there, put a 3y plus 4. But I cannot go around willy-nilly multiplying the bottom of a fraction by something without immediately multiplying the top by that same thing. You guys remember fufu, fancy form of 1? So I'm allowed to multiply top and bottom of a fraction by any number as long as it's the same number. So for example, 2/7, if I decide I'm going to, I don't know, multiply top and bottom by 4, I get 8/28. Is that equal to the 2/7? Sure it is. And so that's how we're going to build our common denominator, is we're going to multiply top and bottom by whatever is missing in the bottom. So you put the 3y plus 4 in the bottom, because that makes the denominator better. And then you put the 3y plus 4 on top because you have to, because you just put it in the bottom. Now I need to introduce some more parentheses, because at the moment it looks like the only thing touching the 3y plus 4 on top is the 2, but that's not right. I'm multiplying the entire bag of stuff upstairs and downstairs by 3y plus 4. Okay, my first denominator is looking pretty good, but my second denominator is missing something. What do I need to put into the second denominator to make it equal the first denominator? There's a y minus 5. And so I'm going to put that in another color right here, y minus 5. And if you multiply the bottom by y minus 5, you immediately have to multiply the top by the same thing. Again, bring in new parentheses here. Lots of colors floating around, but just focus for one moment on those two denominators now. What do you notice? They're the same. That's the key. We made those new denominators the same, which makes adding and subtracting those fractions a lot easier. Makes it doable. Okay, so we're done with the first two fractions. We're going to go there. The last fraction now, we need to complete. We've got to figure out what's missing. Okay, let's see. 3y plus 4. Let's see, we had a 3y plus 4, and we still got a 3y plus 4. We need a y minus 5. Oh, that's fortunate. We have a y minus 5. What do you notice about all three denominators? They're all the same. But if they weren't the same, then maybe you got to put something else in here and the same thing upstairs. And maybe there's something in here that needs to go in here, and then you go back and you put it on the fractions that you just built. Right? It's kind of a methodical process. It takes a little bit of time, but it's not hard as long as you understand the basic concept of fill in what's missing. That's the key. Okay. Equals. All right, I'm going to give you a big old fraction line. Go all the way across your paper. What is the new denominator after I add and subtract all these together? Yeah. It's okay if you write that in the reverse order, but that's the denominator, right? It's just a copy of whatever the old denominators were. Once you've made them the same, you just put one copy. And I like doing that first, because trust me, there's a lot of work we're going to do in the top, and it's easy to forget after we do all the work in the top that we were still supposed to have a denominator in the first place. Oftentimes I see folks get exactly the right numerator, but in the midst of doing all the work, they forget to put the denominator. It's the easiest step. Don't lose a point there. Okay, so I'm just going to copy all of the stuff upstairs with all the parentheses intact. First fraction. What's the next operation after that? Is a plus, right? That was the first fraction. Now we do a plus. Then we do the second fraction. What's the next operation? It's a minus, right? Subtract the last fraction. Hey, sadly, I made another mistake. I'll blame it on the NyQuil. What did I do wrong? Do we need parentheses here? Yeah, it's the same thing Ruth pointed out before on that easier problem. We are subtracting this entire bag of stuff. Well, you better keep it in the bag when you make one fraction. Now it's good. Okay, here's a key moment. There's going to be a temptation at this moment in every one of these add and subtract fractions. And you know, I've been telling you like all semester, avoid temptation. That's been the moral of this class. So here, look, 3y plus, did I make a mistake? No, we're good. 3y plus 4, right there. Right? And then, hey, this is going so well. Y minus 5, right there. Oh, it's so much easier. Why can't I do that? It's addition and subtraction. Right here. It's an addition. I mean, it looks like multiplication, but that's not the main operation up here. That's a big addition and a big subtraction, and you can't cancel when you have that. And the reason that it's dangerous is that because you built the common denominator, look, you put in a 3y plus 4, right? Well, it would be okay to cancel these, but it would be kind of silly, right? Because we're going backwards. You put it there to make a common denominator. Well, that's exactly what I canceled in the purple. It's the 3y plus 4 that I put in. I don't want to cancel it. I want it there. So there's always going to be that temptation, and you always need to say no. Okay, so what we need to do is lots of distributing. We need to get rid of all of these parentheses here. So equals. All right, so this is our, I don't know, foil or lobster claw or monkey face, something. Lots of distributing here. We're going to combine some of the terms in one shot. First times first, 9y squared. Outers, plus 12, let's see. Yeah, outers is plus 12y, inners is plus 6y. We're going to smush them together right now. Plus 18y. Actually, no need to do that in one shot. Plus 12y, plus 6y, less, plus 8. Plus, now we're just distributing the 4. That's the easiest thing up here. 4y minus 20. And then the last guy, minus 7y squared plus 24y plus 28. It's good. Yeah, I definitely forgot the denominator. Make sure you don't forget the denominator. But some other folks had concerned looks on their faces. What did I do wrong? Yeah, Becca. That minus sign comes into everything. I ignored it. I just copied without parentheses. I can't do that. Okay, let's write it the right way. So it should have been minus 24y minus 28. Now we're good. And I'll say I don't think these fraction problems are hard. There's just so many steps and so many details that there's just many opportunities to go wrong. And that's why people struggle with them. No one part of this is hard, but there's like this cumulative effect that makes the whole problem difficult to get right at every step of the problem. Okay, now we're combining like terms. By the way, yeah, thank you, Hugo. By the way, do you remember way back when I said that we factor the denominator, which was already done for us here, and then we don't bother factoring the numerator? You might try a 2x2 box, and who knows, maybe it factors. But imagine that you had factored this, right? That means that right down here, you got these two parentheses. Well, what would you have to do? What did you have to do when we had the two parentheses. We had to distribute, which just sends you right back to where you were. So again, it's not just a waste of time. It actually goes in the opposite direction of what you want. So it really is just factor the denominators and don't do anything with the numerators. Okay, so now it's just careful combining of like terms. Looking for y squareds first. How many? 2y squareds. Some folks like to put check marks or something to help them kind of keep track of all the like terms. That's fine if that works for you. Now we're looking for all the y terms. There's a 12y, there's a 6y, there's a 4y, and there's a minus 24y. Just got to keep track. How much is it? 2y? 18, 22, minus 2. Minus 2y. That sounds good to me. And then finally the constant terms. One vote for minus 40. Any other votes? Minus 40. Yeah, so we are going to factor. What did I omit? The denominator. You gotta have it. You gotta have it the whole time. You might want to write it first. Okay, that answer right there is correct. It is most of the credit of the problem, but it might not be full credit because, again, it's our obligation to simplify, to reduce our fractions at the end of the day. So this is kind of a funky grading thing. If it doesn't factor, if it doesn't reduce, then that's a full credit answer, whether or not you thought about reducing. But if it does reduce and you didn't, then you lose credit. So you really do have to check every time. So I think Jeff points out we can factor out a 2 on the top. So 2 y squared minus y minus 20. That sounds good to me. Copy the denominator. And then what kind of factoring might work in the parentheses upstairs? Greatest common factor? No. Difference of two squares? No. Box? Maybe. In this case, it does. Turns out to be y minus 5, y plus 4. Can we simplify now? Yes, we can. Y minus 5, y minus 5. Before we write the final answer, I want to point out some students feel like if they have these two things here in the denominator that they have to multiply, they have to FOIL or lobster claw, but you don't. And again, it's counterproductive because the only reason that we could see easily that the y minus 5 cancel was that we never bothered, oh goodness, we never bothered distributing this back anyway. So you never have to distribute on the bottom. Just leave it as it is. Even if it didn't reduce, you would just leave it as it is. So final answer here, 2y plus 4 over 3y plus 4. Could distribute the 2 if you want. I'm fine with it as it is. Phew, I am winded after that. Like I said, they're not hard, but there's just a lot of steps. Not hard steps, but a lot of steps. Okay, last thing, and then we'll do some activity stuff. I just want to point out, sometimes you have repeated factors. So a bunch of this is already written out. Let me show you what happens here. Take a look at this denominator compared to this denominator. Okay, we're just going to first complete the first one to whatever it's missing in the second one. I see an x and I see an x minus 1. All right, I see an x minus 1. Good, I've already got that. How about this x plus 5? Do I have that? No, so we give it an x plus 5. Give it downstairs because you want to, and then you give it upstairs because you have to. And we're continuing looking at the green. I see an x minus 1. The first one has an x minus 1. So are we good? We're not good. The second guy's got 2x minus 1s. The first guy needs 2x minus 1s. That's actually the whole point of this example, is to just show you that sometimes you have repeated factors, the same factor more than once. You got to make sure you match them all up. Okay, I'm liking that first denominator. Let's look at the second denominator. What is it missing that the first one has? First one's got an x. Second one doesn't have an x. X on top and bottom. What else does the second denominator need from the first denominator? I don't think it needs anything else. If you just pause and look at those two denominators and just compare, I see 4 factors in both of them. They're not in the same order, but if you just go one at a time, you'll convince yourself it's exactly the same 4 factors, shuffled around a little bit. And that's it. And then you proceed just like the last problem. Okay, so we're not going to go any farther with that one. All right, so you are going to start the activity on the very next page. I want to make a slight change to our calendar here. So I know it says here we're going to do like 28 and then the start of 29 and then Thursday finish 29 and do 30. I will tell you that 29 is exactly the same as 28, what we just finished. It's just more adding and subtracting. The only thing is in 29 is it also gives you multiplication and division. It just mixes them all up. So we did multiplication and division last time and reminded ourselves today. And then the new stuff today was adding and subtracting. So I'm taking 29 off of the table in terms of homework. You never have to do the homework for 29. You just have to get to a place where you know how to add and subtract and multiply and divide. That's all that 29 was supposed to do for you. So for the rest of today, you're just going to work on this activity for 28. On Thursday, we'll come in and do 30, which is a fundamentally different kind of thing than what we did today. The only homework for next time will be 28. Okay, so I will walk around, raise the flag. I'll also check some homework. So check out whatever homework you have, and we'll give you some credit for it.